Good morning, good afternoon, good evening. Welcome back from break, because this won't be released until after vacation, and we're starting into a new unit. Unit test is for Unit 5 is probably in process right now, so make sure you get that in. That will be a third quarter grade. You need to make sure you get that in, and make sure you have enough time so maybe you can do some corrections on it too to get your grade up. All right, we are starting Unit 6, which is called quadratic functions. Quadratic functions have the form f of x equals ax squared plus bx plus c, okay? We've talked about the standard form going from the highest exponent to the lowest exponents. The variables are the x's. The a's, b's, and c's are called coefficients or constants. And most of the time, a will be equal to 1, okay? Which is what we had in our last unit. So we're basically taking, remember the last unit, we didn't have any equal signs. We didn't have this with the equals 10, equals 0, whatever, equals f of x, equals y. Well, now we're going to have that, so we're going from kind of looking at it isolated to looking at it as a function, so it interacts with the input and the output. Okay, so this is the basics for this. Don't stop here. I had somebody stop the video here because they didn't understand what was going on. This is as generic as you can be. This is generalization, and we'll go back and we'll talk about what it looks like when we get into it, so don't stop here, all right? So standard form, same thing, f of x and y are the same thing. So f of x equals y equals ax squared plus bx plus c. A is usually 1. When a is greater than 0, it opens upwards. Okay, that's going to be important. Okay, highlighter. Opens upwards. When a is less than 1, it opens downwards. So what we're going to have is two different things. And I think you've seen this when we've been checking our answers. But if we have our graph, if you have a is greater than 0, that means we're going to have a graph that looks like this. Okay, a smiley, as I refer to them. And if you have a is less than 0, we're going to have a frowny. Okay, and that's going to be important. Part of the things that we look at is how does it open? What does it look like? And we also have an axis of symmetry, okay? And you should remember that from last year when you were doing transformations. We had things that we reflected, and we had an axis of symmetry down the middle of something. So for example, on these, the axis of symmetry would go here or here. Basically, if I fold the paper, it should match up perfectly on both sides if I go through that. And that axis of symmetry has an equation, and that equation is right here. And we'll obviously going to go over this a bunch of different times, but it's negative b over 2a. So you're looking at the b and the a right there going into this formula. So those are going to be important things when we go to decide where the center of our parabola is going to be. All right. And the c, this is something that a lot of people miss. The c is the y-intercept. So if we're looking, did either one of these go through that? So this point right here, that would be that C, right? So those are things you can pay attention to. You can pick up points on this as you go through it. And if you're thinking about it, like, you know that you have the C here, then the point 2 away from the axis of symmetry, those 2 points are going to have the same coordinates. So if you get like half of your parabola going, you can mirror it over that axis of symmetry and get the whole graph. So you can kind of do a little bit less work. And your calculator is going to be super important for you to be able to work with. So keep that in mind as we do this. Your calculator will help you solve these problems. All right, so make sure you get good at it hitting those buttons. All right, sliding on down. Once again, we cover these things again. This is what the graph looks like. This down here is called a vertex. We're going to do some definitions in a minute. And this here is our axis of symmetry. Usually when I draw an axis of symmetry, I draw it as a dotted line because it really isn't part of the graph. All right, you don't want to get yourself confused thinking that the function does like this. Okay, it doesn't do that. It just is that smile. Okay, so it goes down, it goes back up. All right, and when you're drawing these, it needs to be a smooth curve. When you're drawing this, you don't want it to look like that. That's an absolute value. Okay, so you don't want it to come to a point, you want it kind of curve down at the bottom, all right? So sliding on up here, we're going to page 4, and we're just kind of having a quick discussion about limits to a domain. Like if I tell you to graph the function, and we did this back in unit 3. If I say graph y equals 2x plus 3, and then I give you -2 less than x less than or equal to 4, what you should do is draw your graph, but you only are going to do it from -2 to +4. So it looks something like this. And the way I have it, I'd have an open circle down here and a closed circle up there, and that would be my graph. I've limited the domain. That's the only picture I care about. That's what happens when they have something like this, okay? And if you look at this, it tells you that when you do this, you don't put arrows on it. Like what I just did, notice I have the open circle and closed circle. I didn't put arrows on that because they stop right there. The domain is limited. We're going to see this again when we get to piecewise functions next unit. So keep it in mind. If they give you these limits, make sure you exercise those limits. You can't key that into your calculator. It won't do it right now. We'll see how to do that next unit, but this is just going to limit your domain, which will also limit your range. Okay, so the first one, since I have the less than and less than, it's going to be open circles. So at the end, I'd have an open circle to an open circle. All right, the domain is limited, so the range is limited, so no arrows. On the next one, also remember we got the parentheses here. If they say this is an interval notation, and you have the rounded brackets versus the square brackets. Rounded brackets give you open circles, square brackets give you closed circles. Okay, but once again, it still limits the domain, which limits the range, which means there are no arrows. If there are no limits to the domain, that's from infinity to positive, negative infinity to positive infinity, then you do get arrows on the end of it, indicating it goes on forever and ever and ever. All right, and then I got a couple more examples down here at the bottom, and it shows you that when you have the less than or equal to, it includes the -2, so that would be a closed circle, and then you graph it to where it's equal to 6, and that would be an open circle. Then I have it switched around the other way. So we go from -4 with an open circle and then have our closed circle at +8, graphing in between those 2 points, nothing beyond it. All right, so that's just a little review of that because there are some problems we're going to see where we're going to limit our domain. And if they limit the domain, that really means that the good stuff is going to be between those two. So if they're looking for an answer, they're not going to say graph it from -8 to +4, and then what you're looking for is at +27. All right, so that's kind of telling you, hey, look here, this is where the important stuff's going to be. All right, so the next page, page 6. All right, so it says a quadratic function is a function to be written in the form y equals ax squared plus bx plus c. Okay, then it says where a does not equal to 0, and this could be f of x also. All right, where a does not equal 0. Well, why can't you have a equal to 0? Well, if a was equal to 0, that means that this would be 0 and it would kind of disappear. So you would just have bx plus c. And that's really just a line, okay? And this is called the standard form of a quadratic. And the graph of a quadratic function is called a parabola. It's a conic section. If you take the pointy ice cream cone and slice it just to the either side of the point, you would get a parabola when you cut it. That's the way it works, okay? It has an axis of symmetry that divides it into 2 matching halves. The formula for the axis of symmetry is x equals -b over 2a. Let me rewrite that like a fraction. Same thing would be -b over 2a. And we'll see how that works later on in this lesson. The vertex is the high point or low point of the parabola. It can also be called the turning point. So if I graph one of these things, let me just make one up here. All right, and I would have my parabola. We'll do parabola in purple. All right, and well, first of all, this right here would meet at C. We would have our axis of symmetry down the middle, and right down here, that would be our vertex. Okay, and the turning point or vertex, when it opens upward, is positive for x squared. It's a maximum. Well, it's a minimum. Okay, so for the one that I just drew, it's a minimum. Okay, if it was a frowny, it would be a maximum for the turning point when x is negative. And then the last thing I need to point out here are 2 points. It says that the maximum, that's not what it says. It says the roots, zeros, are solution. This is huge. This is going to be a big deal. What we're doing in this whole unit is finding roots, zeros, or solutions. I don't like that color, so I'm going to change it so you can see it better. The root, zeros, or solutions is when it crosses the x-axis, so when y equals 0. So let me mark that off with a couple of bullseyes. Okay. So right there and right there, those are my roots or zeros. Okay, those are going to be huge. We're going to be solving these equations for when y equals 0. It is a lot of work. We're going to learn 3 different ways to do it. We're going to learn it by factoring, which we've already done. We're going to learn to do it by completing the square, which is a little complicated, but once again, it's an algorithm. We've learned the steps. Or we're going to learn the quadratic equation, and you get to hear me sing. I may even have Mr. C sing a little bit too, because he's got the, you know, he got the voice. It's really pretty. Anyway, here we go.
That's a lot.
Yeah. I'm just putting a lot of pressure on him, but it's okay. All right. So page 6. All right. If you didn't get the notes, once again, stop the video, go back and fill in your notes. The notes are important. The vocabulary for this unit is going to be very good for you to learn the whole thing up. All right. So we're going to start off with, this is, whoa, not what I wanted to do. All right. This is called a parent function. This is where the functions start, the simplest form of it. Okay, we've used it before, like we had y equals x. That's the parent function for linear functions. And we have a limit to our domain right there. So that means that if I'm going to graph this, I'm going to do it from -3. Once again, notice I use dotted lines here to +3. I don't care anything beyond that. So -3 and +3. Those are the limits to my domain. Now you're looking at this is y equals x squared. Well, didn't we have y equals ax squared plus bx plus c? And you go, where's the rest? Well, in this case, the b equals 0, the c equals 0, and the a is equal to 1. Once again, that's that magical mystery invisible 1. So there's not a lot going on here. All right. So if we're looking for our axis of symmetry, remember that's x equals -b/2a. Well, that's going to equal -0/2 times 1, which is just 0. Okay, so our axis of symmetry is going to be the y-axis. I'm just going to put a dotted line there. Okay, now to do this, use your calculator. Okay. I mean, you could do this by hand if you wanted to. I don't want to right now. I don't want to confuse you. All right, so here we go. We're going to stick this in our calculator, see what happens. Y equals x squared. I turn on my calculator. I get myself a fresh document. I don't use the scratch pad. I go to graphs. I just type in x squared. X squared. Don't even need to use the caret button. That's it. I hit enter. Smiley face, yay me. But I need to get some points on that, so I do Control T, and I was going to arrow up 1. All right, so I can see that I have 0, 0, 1, 1, 2, 4, 3, 9, and that's as far as I have to go, is because my limits to my domain is at 3. And then I can arrow up the other way and get my negatives, and you can see that it's -1, +1, -2, +4, -3, +9. That's because when you square a number, it's positive. All right, so let's fill in our table. And when I fill in my table, I should put that vertex, that low point, the 0, 0 in the middle. And so -3, -2, -1, 1, 2, 3. And if you think about it, we have 1, 1, 4, 4, 9, 9. So you can see that around that axis of symmetry, you have points that match up with each other. All right. So if I went to graph this, I would start out with my 0, 0. And then I have 1, 1, and negative 1, 1. And then I have 2, 4, and negative 2, 4. And then I have, whoops, I have negative 3, 9 and positive 3, 9. And since these have the lines underneath them, they're going to be closed circles. So I'm going to go up here to 9 and to 9. And then you need to connect your dots. Don't finish this without connecting your dots. And we'll do that, I don't know. We'll do that in green. Smooth curve. Try and hit your dots as best you can. Things that you don't want to do, you don't want to do this. It doesn't go straight up and down, okay? It needs to be going out as you go up and things like that. And make sure you hit the points as best you can. If you don't, erase and start over. All right, so our vertex is at 0, 0. That's our low point, okay? Is a minimum, okay? They didn't ask, but we're just gonna add that because it opens upward. And the 0 is the only spot that it touches the axis is right there. And that's gonna be at, zeros or roots are listed as a set, okay? So what you're gonna do is do a squirrely bracket, okay? That was a nice one. And you're just gonna put a 0 in the middle of it, okay? You do not write it as a point. Your zeros or your solutions or your roots are just the x coordinate. So this is just the x in set brackets. Okay, how are we doing? All right, when you're graphing, you need to have at least 5 points. My table has 7, so I got plenty there, and it should be around the vertex. I mean, I could do 0, 1, 2, 3, 4, 5, 6, 7, but first of all, it'll give me points that aren't on the graph, and it wouldn't give me what I needed to do in order to graph it properly. And the negative 3 to positive 3, we already talked about that. It limits the domain, and that limits the range. Okay, next page. I don't know how long I've been talking for. So this time we have a different one. It's x squared minus 6. We're doing it on the same limited domain. So I'm going to do my negative 3 to positive 3. All right, this time my a is equal to 1 because I have a 1x squared there. My b is equal to 0 again. There's no x term, it's 0x. And then my c is equal to negative 6. All right, so my axis of symmetry, negative b over 2a, is going to be equal to 0 over 2 times 1 again. Negative 0 technically, so it's 0. So my axis of symmetry is still down the middle. So what do you think this minus 6 did to our graph? Okay, did it move it up? Did it move it down? Did it move it left? Did it move it right? Did it turn it upside down? What happened? That's what we need to figure out. So let's just go and turn on the calculator. I still have that original function in there. I'm going to get rid of my table for a second. And then I'm going to hit the tab button. And I'm going to type, whoa. All right. And I'm going to do x squared minus 6. And I hit enter. And you can see it basically slid it down 6 units. Okay. Some people say, well, it made it bigger. It really didn't make it bigger. It just translated it down 6 units. And that's what happened. So I'm going to do the interpretation of that down here. So my roots are going to have to figure out my vertex is at 0, negative 6. And if I go from negative 3 to positive 3, all right, fill in my points. I got negative 6 here. And these would be negative 5 and negative 5. I have to use my brain for a second. Negative 2 and negative 2. And then 3 and 3. I think that makes sense to me. All right, so let me graph that. make sure you count your boxes. I had a bunch of people last year and they did this on a quiz and they counted, they didn't count right. They put it at -5. Okay, don't be that guy. All right, now when I go to graph this, here's one of the things I know when it's just a 1x squared. If I go out 1, I go up 1. If I go out 2, I go up 4. And if I go out 3, I go up 9, because 1 squared is 1, 2 squared is 4, 3 squared is 9. All right, and I draw my thing. All right, so looks pretty good. Now I'm looking for those roots, okay? That's one of the things it's asked me for. It says, hey, where are the roots? All right, and they're right here. Remember, it's where it crosses the x-axis. And if you look at that, you're saying, it's about 2.5. Well, if you just write, it's about 2.5, you're not gonna get very good credit for it because you need to find a little bit more exact than that. All right, so we're gonna figure it out. It says round to the nearest hundredth. All right, so I'm gonna show you 2 different ways to do that. First, I'm gonna show you how to do it with your calculator, or without your calculator. So we know that the roots are where y equals 0. So if I take my equation and replace the y with 0, I get 0 equals x squared minus 6. I move the x to the other, or move the 6 to the other side, and I get 6 is equal to x squared. And then I need to get rid of that squared, so I take the square root of both sides. Here's something super, super important when you do this. When you take a square root, there are 2 answers, a positive and a negative. You need to remember that. So my exact answer for this one is going to be x equals plus or minus the square root of 6. All right? And if you put that in your calculator and round it to the nearest hundredth, that would be a good answer. But I want to show you how to do that in your calculator. And so let's go back over here. And boom. Oh, hold on. Yep, would have been doing it again. All right, and I want to get rid of, well, let's see if I can do this. All right, let's see what happens. I'm going to do menu, analyze graph number 6. I want to find the 0, so I'm going to choose number 1. And it doesn't like me, so I want to do the red. Put the function, okay. No, it's not letting me do that. Let me get a fresh document. We'll just skip this. All right. Hate when that happens. So I'm going to do the x squared minus 6. And I hit enter, menu, 6, 1. My dotted line shows up. All right, so I'm going to click on that and drag it past. Come on. Click. It's grumpy again. Try again. Menu. 6, 1. Click. Come on. All right, third try. Menu. 6, 1. Click. There we go. It's coming. There we go. Yay. Drag it past it and click on it. And you'll see it's at 245, 2.45. If you did the same thing on the other side, it'd be at negative 2.45. So this is going to be squiggly bracket plus or minus, perfectly legit way of doing it, 2.45 squirrely bracket, which is the same as square root of 6. What did the minus 6 do? It translated the function 6 units down. This is going to be a long video, Mr. C. Next one, type this on your calculator. Notice how the parameters changed on this one. We're now doing from -1 to +5. That kind of tells me that my vertex is going to be right in the middle of that. All right, but this time we have an A is equal to 1, B is equal to -4, C is equal to 3, and we want to find our axis of symmetry, we can actually do that negative b over 2a this time. So negative b over 2a is going to give me, watch this, negative from here, and then negative 4 over 2 times 1. And if you simplify that, that's going to be x equals 2. So my axis of symmetry is right in the middle, just like I said, at x equals 2. So now I'm going to put that 2 in the middle here, and I'm going to go 1, 0, negative 1, 3, 4, 5. And let's put this in our calculator and see if we can identify the vertex and the roots and all that kind of good stuff. So let's pull up the calculator, and I'm going to double click on that one and just change it. And minus 4x. Whoa. Oh boy, calculator's not being nice this morning. Especially annoying when you're trying to record. Seriously. All right, here we go. Let's try that again. 2. Okay. X squared minus 4x plus 3 minus 4x plus 3, enter. Okay, we're just going to go to our table, Control T, and I'm going to look at, oh, I got them right there. So I have 0, negative 1, 0, 3, 8 for most of my points. So I have 3, 1, no, 3, 0, negative 1, 0, 3, 8, 8. Okay, so graph it. So 2, negative 1, out 1 and up 1, so 0 and 0, out 2 and up 4, so 3 and 3, and then out 3 and up 9, so that's going to give me 8 and 8. Connect my dots. Okay, the vertex is at 2, comma, negative 1, and the roots, you can pull right out of your table this time. No, I don't want a crayon, I want a highlighter. Are going to be where y equals 0, so you have one here and one here. Once again, when you go to write those, they go in squirrely brackets, and we just write the x coordinates, and so we're going to do 1, comma, 3, squirrely bracket. Okay, and what did the 4x do? That's kind of sketchy. Well, basically, if you divide it by 2, it moved it 2 units to the right. And where do you see the plus 3? That's going to be the y-intercept. And did you notice that the window changed? And that gives us all the good stuff. Once again, they wouldn't give us a window from like negative 5 to 1 over here when we have our vertex and all that stuff on the other side of the axis. All right. So I'd like you guys to take a minute and do the graph on page 9, and then I'm going to come back and put it up quickly and see what happens with it. So see what happens and see if you can answer that question down at the bottom. Like, what did the negative x squared do? Okay, I'm back. Negative 1, 0, 4. The vertex is at 0, comma 4. It's a maximum. The axis of symmetry is at x equals 0, and the roots are at plus or minus 2. Yeah, I'm doing this all in my head. Boom, 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 boom. Nope, that's out too far. And this time they didn't limit the domain, did they? So one of the things I got to make sure I have on here are arrows. Okay, and if I'm filling in my table, I would go from negative 3 to positive 3. Then I would do 4, and then 3 and 3, and then 0 and 0, and then -5 and -5. Once again, they match up across that axis of symmetry. And what did the negative x do? It flipped it, made it a frowny. And did you remember the arrows? Once again, there's no limit to the domain, so you need to have some arrows up there. Okay, so once again, if you didn't do it with the tape stop, make sure you get the information in here and get it all graphed up, because these things are important. The practice is what helps you get it right. Next page, let's do the same thing. You guys try it, then I'm going to do it. So stop the tape. Okay, I'm back. A equals 1, B equals -4, B equals -5. So I know one thing right now, it's going to go through the point 0, -5, because that's my C. It tells me to go from -2 to +6. So 3, 6, a little bit bigger than usual, which tells me that the axis of symmetry should be right in between those two, which should be at +2, but let's find out. So our axis of symmetry is at -b/2a, and that's going to give me -4/2 times 1, which gives me 2. So my axis is at 2. All right, which means that the x coordinate of my vertex is going to be at 2. I just got to figure out where that's going to be. And we're going to figure out my roots. Well, here's one thing I know. If I have 2 units away, I have that 0, -5. That means I'm going to have a 0, -5 there. So if I put my 2 in the middle, just spitballing here, and I have 1, 0, -5, then I have 3, 4, -5. All right. And that makes this going to be -9. And this will be -8. And this is going to be 5, 0, and -1, 0. But they told us to go from -2 to +6, which means I need to go out one more, and that's going to be at 7 and 7. Why do I know that? Well, how did I get the rest of this? Well, I know that this is 2 units away, and 2 squared is equal to 4. So I dropped it down 4. And then I just did what I told you before, out 1 and up 1, out 2 and up 4, out 3 and up 9. And then out 4 and up 16. So I'm going to go here to 2, -9, out 1 and up 1, out 2 and up 4, out 3 and up 9, which gives us my roots. So my roots are -1, 5. And then I go up another 7, 3, 6, 7. And I draw my parabola. Ooh, that was a good one. All right. So that is graphing a parabola. We've identified our roots. We have identified an axis of symmetry. We made sure that we opened up and opened down. When we limited our domain, we stopped and made sure we put closed circles or open circles on there, whatever is appropriate, no arrows. When I didn't have a limited domain, I put arrows on the end of it. And we will be studying this a lot more. Oh, I forgot one thing. This is something, and on quizzes, if you miss this, you lose a point. Is it a minimum or a maximum? It's a minimum because it's a smiley, okay? And I think that's where we're going to stop today. Let me just take a quick look. That just shifts things around a little bit. Yep, that should do us for today. All right. And I think your homework is going to wind up being on Delta or maybe Desmos or somewhere, or maybe I'll just let Mr. C throw something at you. All right. That's what we have for today. That is the first unit in quadratics, unit 6. And enjoy.